Solving system of equations. So when you have a system of equations, these are going to be multiple equations, and we're going to solve both equations. So they're going to have a point of intersection. So system of equation is more than one equation, and then there has to be the same number of unknowns as there are equations. So if you have to solve for both x and y, you have to have two equations, two unknowns, two equations, three unknowns, three equations. When graphing, again, always put your equations in y equals mx plus b. So if we look at this first example, we have the system, and they're usually noted by a little squiggly bracket. So we have y equals x minus 4, and 6y plus 3x equals negative 6. So those are our two equations. We want to graph them and find the value of x and y, which is going to be our point of intersection. So y equals x minus 4 is already in mx plus b. We're going to go ahead and make 6y plus 3x equal negative 6. Put that in y equals mx plus b. So if we have 6y plus 3x equals negative 6, remember you want to get y by itself. So you're going to subtract 3x from both sides. So we have 6y equals negative 3x minus 6. And then we're going to divide both sides by 6. And y is going to end up equaling negative 3 over 6 is going to be a negative 1/2. And then negative 6 divided by 6 is a negative 1. So our first equation is y equals x minus 4. Our second equation is technically y equals negative 1/2 x minus 1. So remember, when graphing, always plot your y-intercept first, which is the b. So negative 4 is going to be plotted at 0, negative 4. And then our slope here is technically 1 over 1. So you're going to go up 1 and to the right 1. And then 3 dots make a line, so you can also go down 1 and to the left 1, and it's still going to give us that positive slope. Two negative movements on the graph give you a positive number. So that is one line. If you wanted to put more, just in case, you can go from this dot, go up 1 and over 1, and we'd have a dot there. And then up 1 and over 1, we technically would have a dot there as well. And then if we wanted to graph the second line, y equals negative 1/2 x minus 1, 0, negative 1 is going to be my first point. And then from there, I have negative 1 over 2, so I'm going to go down 1 and to the right 2. Or I can go up 1 and to the left 2, and that's going to give me my point of intersection right here. So this answer is what makes this system true. So we're over 2 on the x and we're down 2 on the y. So the answer to this system is going to be 2, negative 2. And that's your answer. X equals 2, y equals negative 2. Okay, so let's do another one. So we have 3x plus 4 equals 4y, and then we have negative 4y plus 4 equals negative 3x. So if we were to go ahead and change both of these, again, 3x plus 4 equals 4y. We want to get y by itself. We can technically, I like y being over on the left, so I'm going to move that. I'm going to subtract 4y from both sides. So we'd have negative 4y equals, or plus 3x plus 4 equals 0. And then I'm going to move that 3x, and I'm going to move that 4 at the same time just to save a step. So we'd have negative 4y equals negative 3x minus 4, and I'm going to divide both sides by negative 4. Y is going to end up equaling 3/4 x plus 1. So that's one equation. This becomes y equals 3/4 x plus 1. And then the second one, we have negative 4y plus 4 equals negative 3x. Again, I'm going to move 4 over. Negative 4y is going to equal negative 3x minus 4. And I'm going to divide both sides by negative 4. Y is going to equal 3/4 x plus 1. So this equation also becomes y equals 3/4 x plus 1. So those are technically the same line. So we're going to put our first point at 0, 1. And then from there, I'm going to go up 3, and I'm going to come over 4. And then I can also go down 3 and over 4. So then my line is going to be that, and they're the same line. So when you have a system of equation that works out to be the same line, this is going to be infinite solutions. So when you have only one line, it's the same line, both of them are the same equation, infinite solution. That means any number along this line, and this line goes on for infinity, will make this equation, these equations true. So then the last example for today, we have 2 equals x plus 2y, and we have negative 2y equals negative 6 plus x. So again, switching these, we will have, just moving stuff, negative 2y equals x minus 2, and then dividing both sides by negative 2, y is going to equal negative 1/2 x plus 1. And same thing here, we're going to divide both sides by negative 2. So then y is going to equal 3 minus 1/2 x, or you can say y equals negative 1/2 x plus 3. Now, if you remember anything from Algebra 1 when you guys were graphing slope, if you have the same slope, you're going to have a certain type of line. So these two lines have the same slope. So we're graphing this line, and we are graphing this line. So if you remember what type of lines you're going to have, you're going to see a certain type of solution. Let's go ahead and graph them just in case you don't remember what type of lines have the same slope. So I'm going to graph positive 1 first. I'm then going to go down 1 and over 2. Or I can go up 1 and to the left 2. So that's one line. And then the other one, I'm going to go up to 3. And again, I'm going to go down 1 and over 2. Or I'm going to go up 1 and over 2. And we are going to have our second line. So lines that have the same slope are parallel lines. When you get parallel lines, you're going to have no solution as your answer. So those are the 3 type of problems you can have. You can have one that has a point, you can have an infinite solution, or you can have no solution when graphing. Your homework is a worksheet that is posted on Schoology. Remember, homework stays in with your notes. You do not turn it in. I will check it with your notebook grade at the end of the 9 weeks. Have a good day.